Good day, students. Welcome to mathcodeserve.com. In this clip, we're going to be going over properties of logarithms. Before we take a look at some examples, let's go ahead and do a real quick review on what the properties are. Okay, we're going to be focusing our attention on 4 properties in this presentation. So let's go ahead and take a look at a short review on the properties. Okay, so the first property we're going to be looking at is the product property. That's what it's called. The product property is as follows. If you have log base b of a product, so if your logarithmic argument is a product of 2 variables or numbers or combination of variables and numbers, this can be written as log base b of x plus log base b of y. Okay, so the bottom line is if you have numbers of variables and you're taking the log of a product, it's equivalent to writing it as the sum of the log of the factors that are being multiplied by each other. Okay, so multiplication is equivalent to addition. That's what you want to keep in mind. Property number 2 is known as a quotient property. Okay, quotient is just a fancy word for division. So what if your logarithmic argument is a quotient of 2 terms? In that case, you're going to have a difference. The numerator goes first minus log base b of the denominator. Alright, so just keep in mind the fact that when you're dividing numbers is equivalent to subtracting the logs of the numbers you're dividing. Property 3, power. The power property, if you have log base b of a power x to the n, this one you can just power down your power, okay? You can power this down and then you have, this becomes n log base b of x, okay? So you know x to the n basically indicates repeated multiplication. So when you take the log of the repeated multiplication, you have repeated addition, which condenses into multiplication. Okay, so if you have a power of a term is equivalent to multiplying the log of that term by the power. Okay, now let's go ahead and take a look at the last one, property number 4. That's the inverse property of logarithms. This helps us to eliminate exponents or logarithms from an equation. Okay, so let's say you have log base b of b to the x. Now your exponent and your logarithms have the same base, so they cancel out to give you x. Okay, and then what if you have an exponent raised to a logarithmic expression with a base identical to the base of your exponent? You have cancellation action again, and this becomes x. Okay, so these are the four properties that we're going to be using today. There is a downloadable document with about 11 properties of logarithms. You can feel free to download it and study more in depth about the properties of logs. Alright, so let's take a look at the first example. The instructions are for us to express as a single logarithm and simplify if possible. Okay. Alright, now let's say we have log base 2 of 4 plus log base 2 of 5. Now, if you want to combine, you have to first of all ensure that the bases are identical. If you go back to the properties that we had earlier, you notice that all the bases were identical when we're using the product and quotient properties of logarithms. Okay? So we have to keep that in mind. Now remember, when you're adding logs is equivalent to multiplying the numbers. So this becomes log base 2 of 4 multiplied by 5. Okay? And what is 4 times 5? 4 times 5 is 20. Now can we simplify this? Can we use the inverse property of logarithms to simplify this term? Well, if the logarithmic argument 20 can be written as a power of 2, then we can apply the inverse property. So the question now is, can 20 be written as a power of 2? Let's go ahead and take a look at the powers of 2 real quick. 2 to the 0th power is 1. 2 to the first power is 2. We're trying to see if we hit this number, okay? 2 to the second power is 2 times 2, which is 4. 2 to the third power is 8. 2 to the fourth power, multiply the previous by 2, 16. 2 to the fifth power, multiply 16 by 2. Oh snap, we missed this number. 20 cannot be written as a power of 2. Okay? So what does that mean? It means that we can't simplify this one any further. That's our final answer, expressing this as a single logarithm. Okay, let's take a look at question number 2. What if we have log base 3 of 9 plus log base 3 of 27? Okay, now we have a sum of logs, so that's basically equivalent to multiplying the logarithmic argument. So log base 3 of 9 times 27. Okay, 9 times 27, you have log base 3 of, this is going to be 180 plus 63, which gives us 243. Now, can 243 be written as a power of 3? That's the question. If it can, then we can apply the inverse property to simplify it. Okay, let's go ahead and take a look at our powers of 3. We're going to see if we can end up with 243, okay? So 3 to the 0th power is 1. 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. 3 to the fourth power is 81. 3 to the fifth power is 253. Wow, this is exactly what we want, okay? So 243 can be written as a power of the base, which is 3. So we can rewrite this as log base 3 of 3 to the fifth power. Alright, now we can now use the inverse property of logarithms since the base of the logarithm and the exponents are identical. So they cancel out and we're left with 5 as our final answer. Now for number 3, we're going to try something different. Now what if we have log base 4 of 64 minus log base 4 of 4? We have subtraction of logarithms in this case. Whenever you have subtraction, you divide, okay? The first one goes on the numerator, the second one goes on the denominator, the second logarithmic argument. So when you divide this out, you end up with log base 4, 64 divided by 4. 4 goes into 6 once, remainder 2. 4 goes into 24 6 times. Okay? Now can I write 16 as a power of 4 so that I can apply the inverse property of logarithms to simplify the expression? Well, let's see. 4 to the 0th power is 1. 4 to the first power is 4. 4 to the second power is 16. So it can be done. So let's go ahead and apply that. We have log base 4 of 4 to the second power. Now since these two match, they cancel each other out, and we're left with 2 as our final result. Alright, number 4, let's try another problem involving the quotient property of logarithms. So let's say you have log of 50,000 minus log of 50. Okay, now one thing you'll notice here is that the base is not specified. Whenever the base is not specified, it's known as a common log. Okay, log base 10 is known as your common log. And then whenever you have log base 10, you do not write the base. Alrighty, so that's the whole idea. And then when you have log base e, this is written as ln. This is known as a natural log. So these are the two main types of logs that you will be dealing with, especially when you're entering logarithms into your calculators. These are the main formats that you will see. Okay, so this is log base 10. Keep that in mind, okay? Now, since we are subtracting, if we apply the quotient property of logarithms, this becomes log 50,000 divided by 50. Okay, if we want to reduce that, you can cancel out a 0, equivalent to dividing by 10. 5 goes here 1, 5 goes here 1. So this simplifies into log base 10 of 1000. So the question is, can 1000 be written as a power of 10? Absolutely. 1000 is 10 to the third power. See the number of zeros there? So there's an imaginary 10 here. So it matches the base of the exponential term, so they cancel each other out. And your final answer is going to be 3. Alright, let's do some practice problems focusing mainly on the inverse property of logarithms. So the task here is to simplify if possible. Okay, now let's see. We are on question number 5, I believe. Yes, question 5. Okay, so question 5, what if we are to find log base 2 of 32? Alright, so all you simply have to do is write this as a power of 2 if possible. Okay? Alright, let's take a look at our powers of 2. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is, to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. Voila, this is what we want here. Now, if you do not want to use a list of exponents, you can always decompose your logarithmic argument to see if you end up with factors that are just the product of the base, okay? So this can be rewritten as log base 2 of 2 to the fifth. Now, since the base of your logarithm and the base of the exponents are identical, according to the inverse property of logarithms, those cancel out, and you're simply left with the power. So the answer is 5. Okay, now let's try an example that's slightly more challenging. Question number 6. Now, what if we are to simplify log base 1/3 of 27? Now, in order to apply the inverse property of logarithms, this logarithmic argument, 27, must be written as a power of 1/3. So, can we do this? So you got to remember that 3 to the third power is 27, okay? So 3 to the 0 is 1, 3 to the 1 is 3, 3 to the second power is 9, 3 to the third power is 27. So this is the exponential equation that we will be using to simplify this expression here. Now, first things first, let's express 27 as a power of 3. Okay, so we have log base 1/3 of 3 to the third power. Now, how can you express 3 as 1/3? 3 is a reciprocal of 1/3, or 1/3 is a reciprocal of 3. Okay, so if I reciprocate this 3, what happens to the exponent? Let's go over a rule real quick. Recall your reciprocal property of exponents. If you have x to the n and you reciprocate it, 1 over x, that becomes 1 over x raised to the negative n. Okay, so if you reciprocate the base of an exponent, you basically have to negate the power of the exponential term to compensate for the reciprocation. So what does that mean here? It means that I can reciprocate 3. Imagine there's a 1 underneath. I can reciprocate it to 1/3, but to compensate for that reciprocation, I have to negate the exponent. Bam, just like that. Okay? Now, why did we do that? Well, we are trying to match the base of the exponent with the base of the logarithms. And as you can see, we have accomplished our goal. So we can now apply the inverse property of logarithms to cancel out these two, and you are left with your final answer, which is -3. Okay, let's try another example. This one is a little bit challenging too. What is log base 4 of 8? Now, if you take a look at your powers of 4, 4 to the 0th power, 4 to the first power, 4 to the second power, 8 is not on the list. Okay? It's not that straightforward. So what if we do this? What if we write this as log base 4 of 4 times 2? We have a 4 here, which is perfect. And we have a 2 here. The question is, can we write 2 as a power of 4? Well, we know that 2 to the second power is equal to 4. So what if I take the square root of both sides, or take the half power of both sides? The same thing. If I raise 2 to the 1/2 to the 1/2 power and 4 to the 1/2 power, this tells me that 2 is 4 to the 1/2. Or you can say the square root of 4. The same thing. Okay? Now, let's apply that idea here. So we're going to insert the 2 expressed as a power of 4. So log base 4 of 4 times, instead of 2, we're going to put 4 to the 1/2 power. Okay? Now we're going to now apply the product property of exponents. Whenever you're multiplying exponents of the same base, you add the powers. Okay? So recall, if you have x to the n times x to the m, it's the same thing as x to the n plus m. Okay? Alright, so let's do that here. We're going to have log base 4 of 4 to the 1 plus 1/2. So what's 1 plus 1/2? We express the powers with identical denominators, namely the LCD. So we have 1 over 1 plus 1 over 2. Multiply that by 2 top and bottom. Log base 4 of 4 to the 2 over 2 plus 1 over 2. And then that gives us log base 4 of 4 raised to the 3 over 2. Now, the base of our logarithm is identical to the base of our exponent. We may apply the inverse property of logarithms. This cancels out. Our final answer is 3 over 2. That's why it was challenging, because the result is a fraction. All right, let's take a look at question 8. The last one in this installment. What if we're to evaluate um, with a calculator? Evaluate with a calculator. Here to evaluate log base 3 of 16. Alright, so let's bring out our calculators. We're going to evaluate what log base 3 of 16 is. Now, if you take a look at your calculator, you will see that you have just log, which is log base 10, your common log, and your natural logarithm, log base e. You do not have log base 3 here. Okay? So your calculator does not understand log base 3. It doesn't speak that language. So what we have to do is we have to translate this expression into a base that the calculator understands, namely log base 10 or log base e, the natural logarithm. We are going to implement something called the change of base formula here. So let's go over that real quick. So something you want to note, side note, if you want to change from base n to m, let's say we had log base n of x, and we want to change this to log base m. This becomes log base m on the top, log base m on the bottom. You take the logarithmic argument x, that will be the logarithmic argument of your numerator term, log base m of x, and then the base right here becomes the logarithmic argument of your denominator. So you have an n right over there. Alright, so there goes the change of base formula. Alrighty, we're going to apply it here. We want to change it to log base 10 or log base e, which is ln. Let's do log base 10. Okay, so this is now going to become log base 10. Do not write the base for log base 10, it's not necessary. So we have log base 10 on the top and also log base 10 on the bottom. So you take the logarithmic argument, namely 16, that goes on the top. So you have 16 divided by what? You take the base, okay, and then you stick that in the denominator over 3. So our calculator understands this expression because it's written in log base 10. Okay, so our answer is going to be log base 16 divided by log of 3, labeled base 10. Okay, so we have 2.5237. This is approximately 2.5237 to 4 decimal places. Thank you so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your study of logarithms, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions about the contents we covered in this presentation, just place your questions in the comment section below, and we'll be more than glad to support you. We constantly update our YouTube page with math tutorials, so do subscribe to our channel so you can get updates to those new videos. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day. Goodbye.